the other configurations are there, what you do? You draw the symbol vertical. You draw your symbol vertical. In common base, I have drawn the symbol horizontally. So now what is the next topic? Yeah, come with me. What is the next topic? Common emitter configuration. So consider this as base, this as collector, this as emitter. Which is grounded now? Emitter will be grounded. Make it as grounded. And mention them as N, P, M for your better understanding purpose. Now this, I have just named it as NPN, but it will not become a NPN transistor. It is simply a BJT. If you draw arrow mark, then it will become NPN transistor. In NPN transistor, current will flow from base to emitter. In the symbol, you go through those symbols. You should draw this symbol. If you won't draw this symbol, this will become just a BJT. It will not become a NPN transistor. You have to draw this diagram, this arrow mark. You have to show indication. Current is moving from base to emitter. Now I want to study input and output characteristics. This is my input. My collector is what? My collector is output. This is my input terminal. My collector is output terminal. What is that? Beta. In common emitter configuration, beta is equal to delta IC by delta IB. If you remember alpha, beta, gamma formula, you can draw this circuit diagram. Understandable? Those are the constant. Alpha in common base configuration, alpha is equal to delta IC by delta IB. IB only. IE. In this configuration, delta IC by delta IB. IC is your output, IB is your input. So what I will do? I will connect an ammeter, a voltmeter. Same thing here. Here also an ammeter and a voltmeter. Then what will connect here again? What is connect? A variable resistance. A variable resistance here. And whatever here it is, this is the source. I'll let you know later. Here also a variable resistance. And here a source. Done. So you have to give a name. What you will give this name? This is IB. The current which is flowing the base IB. What you name it here? V, VER, VEB. Whatever it is. VE, VEB, whatever you want to mention. And what about this current? IC. And what is this voltage? VCE. VCE. You need to draw the polarity in the diagram if they are available. Draw the polarities minus plus, whatever it is. Clear, understandable? Understood with the circuit implementation? And you can make a round off like this here. That is become a NPN transistor. Now, EB. What is this junction? Emitter base junction, which is always forward bias. You can write down this for a better understanding purpose in the diagram. You write down like this. So what will connect here? P2. Which terminal? Which polarity? Positive. P to positive, N to negative. Done? That is why I am connecting. Positive to the positive, negative to the negative. I am connecting negatively. This is positive, this is negative. Negative, positive. Plus, minus. Positive to the this on your diagram. Just look at in the diagram. Connect the polarities. Plus or minus, whatever it is in the diagram. Go through those lines. Understandable? So, positive to the positive, negative to the negative. This will become B. Understandable? Now what will connect here now? N to positive, this side, this is grounded. P to negative. Understandable? This terminal is grounded. N to positive, P to negative. This is positive, negative, positive, negative. Clear? This will become VCC. Source. Understandable? Say some.
Yes, sir.
Clear? Now what is your input characteristics? What will be on x-axis? What will be in your x-axis? VBE. Just change this as VBE. VBE. What is on your y-axis? IB. Base current. Just change whatever it is. Your wish. You can change in steps of 0.1, 1, 2, 3, 4, 5, 0.1, 0.2, 0.3, whatever it is. So here, as EB is forward bias, what will happen? We'll keep VCE as constant. First case, VCE is equal to 0. I'm telling VCE is equal to 0. Same thing, the same graph. As PN junction diode is forward bias, current increases rapidly. Clear? My second case is I'll make VCE greater than 1. VCE greater than 1. In this case, the graph will shift towards right side. VCE is greater than 1. Same PN junction diode under forward bias characteristics. The junction will behave like a PN junction diode under forward bias as EB is forward. Clear? Clear this? So whatever the parameters available at the input side, you will vary. You will note down IB current. You will keep VCE and IC as constant. You won't touch them. Just make it as 0. Second case, make it as 1. Don't touch those voltmeter and ammeter. We will touch only the ammeter or voltmeter which are available at the input. Understandable? Now what will be your output characteristics? What is your x-axis? What is your x-axis? VCE. What is your y-axis? IC. So same thing you will get like this kind of waveform, but there is a small change. Like this kind of waveform you will get. Focus here, don't discuss. This as O, make it as A. IC 5, 10, 15, 20, 25, 30. Listen here, focus here. Whatever I am editing as this is your saturation region. This middle section, the center section is active region. Whatever this is nothing but cutoff region. I'll explain those now. So here it is IB. Previously it had IB is equal to 0, 10, 20, 30, 40. IB is equal to 50 milliamp micro, whatever. In order to study output characteristics, my first case IB is equal to 0. And vary VCE 1, 2, 3, 4, 5, 6. What I will note down? IC. What is our y-axis? IC. I will note down IC. My second case, IB is equal to 10. Keep it as constant. We will vary VCB. You will repeat it. 1, 2, 3, 4, 5, 6. Again you will note down IC. Third case, 20, 30, 40, 50. Like that you will repeat. You will vary VC and you will note down IC. Understandable? Say some. Same, you will get these kind of graphs, you will get these kind of curves. Here also, IC is independent of VCE. These curves are parallel to x-axis. IC is not dependent on VCE. IC is independent of VCE. Understandable? Say some. Say some.
Yes, sir.
Let me explain you what is that saturation. You need to focus properly and I will give a hint also. Yes means what? Saturation region. Focus here. By using this graph only, I will tell you, I will define you what you mean by saturation region. By using this graph, I will define you saturation, active and cutoff region. So in this region, what is this? Region means space. That is a space. You guys have occupied Those are the bench. That is the student space. This is dais. Understandable? You can say region. You can say space. Focus here. This is O and this is A. If your name starts with yes, you can write down yes, whatever it is. So look at here. The space, the region. To the left of the curve OA. What is this? Don't say it as a line. The curve, the region, the space. To the left of the curve OA. That region is called as saturation region. This is one definition. One more. In this region, both emitter base junction and collector base junctions are under forward bias. In this region, what I am telling, emitter base junction and collector base junction both are forward bias. Will prove you. Listen here. IC is here. Collector base junction, I have a current. I have a current IC in this region. Even I have a current IB. See, listen here. This is IB. This is IB. This is IB. This is IB. I have both the current. Say some. I have IC and I have IB also. Understandable? Where? In this area, in this region. That's why EB and CB are under forward bias. Understandable? Say some. Say some. Yes, now I go to cutoff region. This region what? Cutoff region. In this region, or I will define you. Listen here. The region, the space. Below IB is equal to 0 milliamp. Whatever the space, whatever the region is there, below this, that region is called as cutoff region. This is one definition. Now let me tell you another definition. In this region, in this space, both EB and CB are under reverse bias. What I am telling? In this region, both emitter base junction and collector base junctions are reverse bias. Why? This is 0. IB is also what? 0. IC is also what? 0. That's why both the junctions are under reverse bias. Understandable? Clear? Now what is the last region? What is the last region? Active. So in this region, EB is under forward bias, CB is under reverse. Because here I have only IB current. That current I have. EB is forward bias. I don't have IC current. In this region I don't have IC. IC is 0. That's why EB is forward bias, CB is reverse bias. If it is reverse bias, IC will be 0. I don't have IC current in this region. The central region which is available in this graph, the middle portion, that is called as active region. Overall, one more name is linear region. Understandable? Understood the definition? Say some. Saturation, cutoff, active. Clear? Say some. Say some. So I will tell you one more point. Focus here. How you can remember. How you can remember. What is the spelling of saturation? What is the spelling of saturation? Okay. I have wrote it as capital ON. In saturation region, the transistor will be in ON condition. Saturation. Transistor will be in ON condition. In what is the spelling of cutoff? CUT off. In cutoff region, your transistor will be in off condition. Understandable? Just remember the spelling. Saturation. At the end, I am having ON. Your NPN transistor will be in on condition. In cutoff region, cutoff space, your transistor will be in off condition. On, off, on, off, on, off, on, off. What will happen? On, off, on, off, on, off. What will happen? What is that? Switch. Like this, the transistor will act as a switch in saturation, right? Cutoff region. Understandable? On, off, on, off. Now what about the active region? inactive region, your transistor will act as a linear amplifier. Now I want to reach my voice up to there, though I am shouting. What I will use if I want to reach my voice up to there? What I will use? I will use a mic. I want, because I have some throat issue, or I want to give a speech, or it is not a speech. Politicians will give a speech. What they will use? They will use a mic. Inside the mic, you have a transistor that is in active region. That is a linear amplifier that will amplify the voice signal. Amplification means increasing the strength of a signal. If you get a boost is the secret of pure energy, boost is the secret of high energy. Don't talk, listen here. Then what you have? You get energy. Like that, amplifier will increase the strength of a voice signal. Like that, your transistor will be act as a amplifier in linear region. In saturation and cutoff region, it will act as a switch. Clear? So the next topic is that is only how transistor act as a switch.